prowadzony w języku angielskim. Po prezentacji zrobimy sesję Q&A, także zachęcam zadawać pytania na czacie, albo gdyby Państwo chcieli zabrać głos po prezentacji, proszę też zgłosić taką chęć na czacie i dopuszczę Państwa do mikrofonu. And now we'll continue in English. Welcome everyone once again to our webinar series, Knowledge Has Layers. As I mentioned in Polish, we will have a Q&A session after the presentation. So if you want to ask a question, please ask them on the chat, or if you want to ask it out loud, write that you want to ask something in the chat, and I'll give you the mic when the time will come. And okay, now to the most important part of our meeting. It's a pleasure to introduce our guest. He's an EVP Sales in Nanofabrica, Avi Cohen. So yeah, without further explanations, the floor is yours. But one more thing, I guess your presentation stopped sharing. So yes, giving the word to you.
Okay, I will share it in a second, but first I want to thank you, Anna, and I want to thank the organizers for giving the stage for this sharing with you some new things. I want to, before we start, and it's very important for me to say a few words about myself, just for you to understand the background of where we are. I've been part of the additive manufacturing industry for the last 22 years, since the late 90s. And it was a pleasure for me to be part of an industry of 3D printing that before people knew what 3D printing is. Back in these days, people didn't know, they knew when you say 3D printing, they said, printing, I know what it is, 3D what? Today, everybody knows, I guess, what is 3D printing. But the reason I'm sharing it with you is that over the years, from the beginning, people wanted to print parts, I remember, and then they come in another exhibition and want the tray to be bigger and building envelope bigger and bigger, and we need 2 more inches and few more centimeters, and I want to print the bumper of a car. But nobody then stopped and says, wait a moment, can you print smaller and smaller and smaller and smaller? And can you print in 1 micron resolution in X, Y, Z, tiny little parts? These days, these years, things are happening because most things that you produce become smaller and smaller. And the only limitation sometimes, or part of the limitations, is the ability to print small parts, cases or whatever. Everybody wants everything to be smaller, and this is what Nanofabrica is doing. So I will start with sharing my presentation, and I hope that it will go smooth. Now I need to see how I change slides. That's technology. Okay, so without, like Anna said, without further ado, I will go ahead and start. I will not talk much about 3D printing, only a few words here and there. I assume that most of the audience aware what 3D printing is, and more will focus about micro additive manufacturing or micro parts, how this technology works and what people are doing with the machine and so on. Can you see my slides progressing?
Yes, everything works perfectly.
Everything works good. So in 3D printing, one of the most common usages from one end is to do short runs of parts or customization. And I'm still a big believer, it will surprise you maybe, but I'm still a big believer that not everything will be done with 3D printing. No. I belong to those that believe that if you need 2 million spoons, go ahead and make them in traditional way. It will be faster and cheaper and better than to print 1 million spoons that will be more expensive. But the moment each one is different or you need short runs, this is where 3D printing definitely takes its place. We are talking about printing really small parts with features and details, and our printing resolution is in X and Y 1.9 micron. With a layer of 1 micron and 1.9 micron pixel, you are able to print really things that are with more features than your fingerprints. If we look at, I'm starting with few samples just to take you to understand what are microparts. If we look at this filter, medical filter, you can see the scale 1 millimeter at the bottom right. This filter has 580 holes. Each one is 50 micron. That's an amazing number of holes, all of them open in this filter, tiny little parts. That when you hold it look like a rice grain, but to understand that things like that becomes to be feasible. And we do have some customers from the medical devices that printing things they could not do before, like a insulin pump that you carry with you, something very, very tiny, little small that they could not do all the mechanics before they met the micro additive manufacturing solutions. The pyramid here, which is again about 1 millimeter size, is not about to show the usage, but the feature, the detail, the sharpness of the capabilities that you can get while using the Nanofabrica equipment. The whole micro additive manufacturing is still relatively virgin land, and not many people are aware that you can print a 1 millimeter impeller with 70 micron blade thickness. Now you can ask why people need it. Who needs anyway microparts? And surprisingly, we find that there is a need and a high demand in different aspects of life in the industry. The part that you see here belong to the optic fiber connectors and adapters. Optic fibers vary between 130 micron in the civil industry to 250 micron in the military spec. But they all need to be connected somehow, and many people find out that there is a big usage for printing the parts. Can be for end user parts or prototyping or production, but this is a big industry using also micro additive manufacturing. About filtration, I also spoke a bit before, so you understand the usage, or you can imagine the usage of medical or others micro filters. This shape is presented here only to show you that the 1 micron layer thickness with the pixel size, if you can imagine this is a 1 millimeter part, then you really understand that what you see is not only the smooth surfaces, but the details, the rounded holes and features that you can get on a 1 millimeter cube. You need not to get mistaken, the machine can print much bigger parts than this, and you can print 50 millimeter cube, but it's important to show the features and the details that you can get in every part. The optical world from a mobile phone and others, all using different type of lens holders and equipment that definitely can use the micro additive manufacturing parts. And I think this is the last one before we go next. Part like this, again, you can imagine that they are all presented here. They are 1 or few millimeter size features and details of the parts that was printed and shown here. About 50% of the people that approach us are interested in parts for the end use, and the other 50% normally is interested to print the mold. In this picture, you can see your laptop, the button of the letter N. So if you look at your laptop, if you're using a laptop and the letter N on your laptop, this was pictured there. And the pink part was injected to our printed mold. You can see the nice sharp corners of the wheel, and of course the letters, the characters that on top of it. So customers are using the parts to print. They call it insert because one mold can have many inserts, but we can call it mold to make it simple. And injecting to the mold different type of materials, PE, PP, ABS, delirines, and others. And of course, the industrial usage of the parts. But let's go to the main highlight. How does it work? How this technology works, and what is the ability to bring you micro parts in micro resolution. This is a little bit illustration, but just after that there is a movie that shows you in more details. So I'm just preparing your understanding before we see the movie. I will put it in a pictorial way so it will not sound too complex for you. At the bottom of our equipment, there is the DLP on the left picture on the bottom, a LED DLP, which is a digital light processor, like a projector. It projects a picture of 6 mm by 9. This micro projector developed is in the resolution of 4K. That means if you take your television with the 4K television, and instead of the size of your very big television in your house, imagine that everything is minimized to be 6 mm, not 60 or 80-inch television, but 6 mm. That's what we are projecting, 4K on a 6 mm size. On top of it, there is a adaptive smart optic system that's sitting on this projection system, sharpen and control the ability to get online, to get the ability of sharp and tested and equal pixels in every point. But 6 mm projection, it's a very small part, and we want to print big parts. So the whole assembly of this projection and the optics, the complex optics, is sitting on a very massive granite table and is moving on a movement system along the X and Y. So we are projecting a 6 mm picture and moving to the right or to the left and traveling. Why do you need a very massive granite table? Because we wanted to maintain a very high tolerances of the movement without even the shrinkage of metal parts. And today our movement system is accurate by 100 nano. That's a very, very accurate, similar to semiconductor industry. And the last one, the materials, when you need to print on 1 micron layers and tiny little micron pixels, your material needs to be adjusted and developed to control it and not to expand in heat or change the properties of the materials. All this together bring us to our technology. This is the first time that I'm trying this new movie on a webinar. So let's see if it works well, because it's open a link to YouTube. So let's cross the fingers that you can see what I'm about to show.
Okay.
Now it's okay before I continue?
Yes,
yeah.
It's perfect.
Okay, it seems like we're having some hard time.
Yes, if I think there might be the limits of the platform after the actualization or something. But yeah, I think we will have to continue without ending the video.
All right. So I will go back to my presentation. So we were talking about the ability, and I think I mentioned before in the illustration, projecting like a 4K picture and moving the system with adaptive optic, everything sitting on granite table, the whole machine chassis, and projecting and moving every tile like this and getting the micron pixel size and 1.9 micron the pixel and 1 micron the layer. This is the machine as it looks. This is the real machine. It's not a Photoshop. This is how the machine looks. The name Terra 250, just to share with you, if you know that the pixel is 1.9 and the layer is 1, then the voxel, which is the three-dimensional picture, is there, and the total number of voxels for our building envelope is 250 tera. That's the total number of voxel three-dimensional pixels that we have in our machine. That's a huge number of data that we can print. The movie is also available in our website, Nanofabrica website, in the technology tab, so you can always take a look there. I learned, by the way, that in the webinars, it's also difficult to show movies, so I apologize. First time I'm doing it here. So we talked about the resolution, 1.9 micron, and the tolerances, and the surface finish, and the layer thickness. And the building print time is 1 millimeter height per hour for the complete building envelope. At the moment, the first material that we released was a ABS-like material, which called the Precision N800. That was an ABS material, a plastic, and following it, we are releasing a composite material, which is a material that is loaded or enforced composite with ceramic of around 50% loading. That means 50% of the liquid will be nanoparticles of ceramic. It's not a ceramic material, it's a plastic enforced with ceramic particles, nano inside, that giving you a higher temperature resistance, wear resistance, and other properties that allows you to use it. Imagine that you want to print some wheels or gears that will handle many, many years ahead, and you need them very strong, so you can do that with this composite material. The software that was developed in the process was also a very big part. I will not bother here too much but can give you just some ideas. How do you project? Do you project the whole picture, part of it? First of all, the boundaries of the parts, and then inside. A lot of tricks that were developed and a lot of patents that were found to support our high resolution micron additive manufacturing system. Some of the parts here are very small, but this is the less interesting ones. Let's go to the application side. Let's see what people are doing with this printing. We are posting sometimes in LinkedIn and other media different parts that customers are doing. Most of the mechanical parts people like, but the days I posted the Harry Potter castle, the Hogarth castle on the left, this got like 1 million viewers, and a lot of people were amazed by the features and details of the Harry Potter castle. So imagine like a 2 millimeter part length that has so many features and details, and this is the Harry Potter, so it took a lot of attention. So looking at different type of usages, it starts from typical micro parts in additive manufacturing, different mechanical parts, gear shafts. You remember I told you about the micro insulin pump. So just for example, a lot of gears inside and cases. In electronics, a lot of tiny little connectors. Electronics can go very, very small today, but what about the casing or the connectors that cannot become that small anymore? And this is where they use our equipment. Again, it can be also gaskets and packaging in electronics and jigs and pick and place in semiconductors that using it a lot and so on. You can see the size on the right, our part versus a screw, just to understand how small you can get. Medical devices and filtration, I think we already discussed about this one, so we covered this. Microfluidics and the ability to print tiny little holes, 20 micron radius or up, is also a very big market. Many of you maybe know Elon Musk. When you say Elon Musk, you think about Tesla or SpaceX, but Elon Musk have another company that called Neuralink that just recently did a very nice test with chimpanzees and to connect their mind to actual computers. The idea was to assist paralyzed people, but for this they needed tiny little micro nozzles for needles, and they were very happy to use our equipment and to see that they can print equipment to deliver the micro needles and electronic probes that connected to this medical operation. In optics, growing industry, we also discussed mainly they are using it for lenses holders and others, lenses mounting or similar parts. We talked about mold. Let's print the mold. Instead of printing the part, let's print the mold. We can inject any material we want in any color we want. Anyway, it's a small mold, so we can print many in one shot. That's also a possibility. To share with you that the micro injection molding machine is different than what you think. If you know injection machine, 30 ton, 50 ton, very big, very expensive. Micro injection molding machine is very low cost, less than 10,000 euros. It's even a desktop or a bench device, doesn't take much place. We don't forget, we inject 1 gram, not 500 gram. So it's a very small and light equipment. So people tend to use it in different type of cases. And here you can see different type of printed inserts for molds that being used by different type of customers. Another nice part, it's also in the LinkedIn, you can see these 2 kids jumping one on top of another. You can see the finger and understand, you can see their fingers. And if you look very deep, you can really see a lot of features and details in this model that is really, really tiny little one. So you can now realize and understand what you can get. That brings my 30 minutes presentation to its end, not without giving you enough time to ask questions and answers. And I want to thank the organizers for arranging the event and share with you. It was in a little tasting what is micro additive and how this technology works. And I will stop the presentation now. I think it stopped, and share with you again, and be happy to answer any question that anybody have. And Anna, the stage is yours again.
Thank you so much. I'm really sad that it wasn't so smoothly with the video, but everyone has a link on the chat. So if anyone wants to see the full version, please copy the link and you can use it and see it by yourself. And yeah, please ask question on the chat, or if you want to ask it live, please mention that you want to do it in the chat, and I'll give you the mic.
Yes. I can also add, Anna, maybe if the people didn't feel comfortable or the question didn't come up now, but let's say tomorrow they wake up and they say, aha, I want to ask something, they can always come back and ask.
But we have one question already, so please take the mic, Mateusz.
Can you hear me?
Yes.
Is there possibility to use other materials in this technology than ABS?
A very good question. The answer is yes and no. Why yes and no? Yes, you can use. The machine is not locked by any means. So if you have the machine in your facility and you decided to put something else inside, no damage will be done. You put your material, you try, and if you like it, you have a winner. If you don't like it, you didn't lose anything, and again, no damage done. Why did I say no? Because the whole idea was how you control. It's not just to cure the material, but to make sure that every pixel stays there, the place you wanted it, and to control the 1 micron layer. But if you have, and we are, by the way, encouraging also relationships. So if anybody is relation with a very big material company that want to try, we are very much open. And I want to share with you something about the commercial aspect, just for you to understand. Most 3D printing companies, they sell the material and the machine. It's like the razor and blade concept. They sell you the machine and you need to buy materials. And this is their major income, the materials. But what happened, do you know how much material our customers spend here? It's negligible, really, because you can print 10 parts, 3 grams, 10 grams, the waste is minimal, 50 grams a day. That's really not much. So you will consume 1 liter per 3 months, if you know what I mean. So this is why we are looking at things a little bit different than locking the materials and not letting others use them. I hope I answered the question.
Thank you. The next question, is it possible to print biological parts, for example, medical drugs, in very small sizes using this technology?
The answer is yes, you can. We are in the process of biocompatibility approvals. I did this process in my past life. I've been working at Stratasys or Object for 16 years and submitted similar materials for medical approvals. So I know that it is feasible in the way. At the moment today, we do not have it yet, but the medical approvals are in process.
Thank you so much.
Somebody, one more. We need one more. No volunteers.
Okay, maybe if someone will have like specific. Oh, the third question. Why is the building envelope round and not square?
Actually, it is square. The projection is square. Good eyes. I like this guy. Who was it?
Franz Koinen? I'm sorry if I mispronounced.
Koinen. So the
Thank
answer, you have a very good eyes and catch. The projection is rectangular. The tray, it can be rounded, can be any shape, but inside the projection, so it's like 70 millimeter diameter, but we are projecting on 50. So we are projecting rectangular. So the rounded shape was, not important at the time. But I want to share with you, take it from there. But this shows that this technology is scalable. That means the printing area today is 50 by 50, but there is no limit to make the machine like we have Tera 250. We can make Tera 350 or 500. No limit to increase the building size with this technology. But the tray is not important. The projection is indeed rectangular in the middle. Good.
Great. I think if someone wants to have more specific answer or questions, they can write. You can write or on my mail, and I will direct you to Abi or directly to Abi. Yes.
Yes, indeed.
So, anyone more questions? Okay, I think we will finish. Thank you so much for your presentation. That was really interesting, an amazing technology, and an amazing presentation. Thank you everyone for participation in our webinar. We have one more webinar for today. It will start at 2 p.m. So welcome. Yes, everyone have a nice day. Thank you so much for the participation. Big thanks to our speaker.
Thank you for organizing it. And all of you, take care and please be safe.
Thank you for sharing your knowledge with us.
Sure. All the best.
Okay, see you in the next webinars and have a nice day.
Thank you. Bye-bye.
Bye-bye.